that is the laws of thermochemistry. An important scientist known as Hess was able to propose an important law, okay? So the first law, or the most important law of thermochemistry, is the what? Hess Law. Now, what is this Hess Law saying? The Hess Law is simply saying that for a reaction to proceed, that proceeds in several steps. I repeat myself again. For a reaction that proceeds in several steps, the overall enthalpy change is equal to the sum of the individual steps. The overall enthalpy change is equal to the sum of the individual steps taken to arrive at that reaction. So now, look at this expression on the board. Look at the reactant. Look at the product. There are several ways you can arrive at this product. Let me just explain the Hess Law for you in a simple term. There are several ways you can arrive at this final product. We can move through the intermediate B, through the intermediate C, and finally get to the product. Look at the arrow signs. Look at the arrow signs. Look at the signs of the arrow showing the direction. We can move through this route and arrive at this product, while we can also move just by this route. So according to the Hess Law, the Hess Law, this movement is equal to this movement. No matter the path you are following, the sum of the enthalpy is equal to this one here. So we can say that the sum of the clockwise moment is equal to the sum of the anti-clockwise moments for this. Now, mathematically, we can say that delta H1 for this first one plus delta H2 plus delta H3 is equal to delta H4. Okay? We can also rewrite this expression as saying that delta H1 plus delta H2 plus delta H3 minus delta H4 is equal to 0. So what this means is that a complete cycle of this reaction will give us an enthalpy of what? 0. So the Hess Law is an important law that we use in quantifying or calculating or trying to figure out the heat of reaction that is used for every reaction. So for this particular Hess Law, just understand the concept behind the Hess Law. It's just saying that no matter the path you are taking, the sum total of that path is equal to 0. It's equal to 0. Okay? So the sum of the clockwise moment is equal to the sum of the what? Anti-clockwise moment, regardless of the path we are taking. The second thermochemical law, aside the Hess Law, is this law on the board now, which states that the formation of a compound involves the same amount of heat in the opposite sign to the decomposition of the same compound to its reaction at the same temperature and pressure. Now, in summary, the heat of forward reaction is equal to the backward reaction but opposite in sign. What this law is simply saying is that if I have something like, let's say we have carbon plus oxygen to give us CO2, and the delta H for this guy is minus 393 kilojoules. We are saying that if we reverse this equation, so far as this is the equation, and you reverse it under the same temperature and pressure, you reverse it, CO2 to give us C plus O2. The delta H for this guy will be the same value but opposite in sign, which is the negative sign will turn to plus sign. This is what this law is simply trying to say. At the same temperature and pressure, so far as the same reaction, reverse it, you get the same value for different what? Sign. So this is simply the second law of thermochemistry. So the next video will be on the what? Applications of this law and simple calculations we can perform using these laws we have learned.